Section A. Lewis structures.
Since most of organic chemistry focuses on molecules, organic chemists have a special way of drawing organic molecules using the atomic symbols from the periodic table. When organic chemists draw molecules, they represent each of the different atoms of the molecule using the individual atom symbol from the periodic table.
To represent carbon, we use its atomic symbol, the letter C. When we draw this C to represent carbon, the C indicates the nucleus of the atom.
Atoms are made of three core components: protons, neutrons, and electrons. Electrons surround the nucleus in orbitals. The electrons in the outermost orbitals are called the valence electrons.
Generally, valence electrons are responsible for how atoms behave in reactions. Most of organic chemistry is concerned with what these valence electrons are doing, so we need to get really acquainted with them.
The periodic table tells us how many total electrons an atom has, and also tells us how many outer valence electrons that same atom has. Let's check out carbon. Its atomic number is 6. This tells us that carbon has 6 protons and 6 electrons. But total electrons are different from valence electrons, which are the electrons that actually participate in reactions.
You'll probably remember from general chemistry that electrons are arranged in orbitals. The first 2 electrons are in the orbital closest to the nucleus. This orbital can only hold 2 electrons, so the 4 remaining electrons move to an outer shell, where they can participate in all sorts of fun reactions.
Chemists have a handy bookkeeping device to keep track of these outer electrons. It's called the Lewis structure. In a Lewis structure, the valence electrons of an atom are indicated by a series of dots.
The periodic table is an absolutely ingenious tool, just like the salad shooter. A really easy way to figure out how many valence electrons an atom has is to simply see the number of the column the atom is in. Carbon is in column 4A on the periodic table, so we know it's got 4 valence electrons.
Carbon's Lewis structure looks like this. We draw a capital C to represent the nucleus of the carbon atom, and then we draw 4 dots around the C to represent carbon's 4 valence electrons.
We can now form symbols for any of the elements on the periodic table which are important to you, the organic chemist.
Here are the Lewis structures for hydrogen with 1 valence electron, nitrogen with 5 valence electrons, oxygen with 6 valence electrons, fluorine with 7 valence electrons, and chlorine with 7 valence electrons as well.
The molecular formula for water is H2O. That tells us that one molecule of water consists of 1 oxygen atom attached to 2 hydrogens. But that doesn't tell us anything about what water's structure looks like.
When we draw the overall structure for water, we get a figure that looks like this, with 1 oxygen atom connected to 2 hydrogens.
Why does that one atom of oxygen in the water molecule choose 2 hydrogens and not, say, 12 hydrogens?
The reason for this introduces one of the central concepts in all of chemistry. Do you see all these elements here, from lithium to fluorine, and all the elements beneath them? Well, they all want 8 electrons around them.
One major exception is hydrogen, which only needs 2 electrons around it to feel good about itself.
Outer valence shells are complete with 8 electrons. In other words, the atom is most comfortable with 8 electrons in its outer shell, so it'll do what it must to make it so. Oxygen has only 6 electrons in its outer valence shell, so it needs 2 more electrons to complete its outer shell. It can find 2 more electrons by hooking up with 2 hydrogens, which each have 1 electron.
The Lewis structure for water looks like this. Oxygen gets 6 dots representing its 6 outer valence electrons. These 2 electrons are called an electron pair, as are these 2 electrons here. But then there are 2 unshared valence electrons. The first hydrogen will bond to one of these unshared electrons with its 1 electron, and another hydrogen will hook up with